Direct AI. This is me, Sachin, and today we are going to discuss about how you can select the best model from multiple learning machine learning models with their subsequent hyperparameters, which are best tuned from a grid. Now, this is in extension with the previous tutorial that we had on model selection using grid search CV and the randomized search CV. This extends the functionality to along with selecting the best hyperparameters, it lets you select the best model as well from a given search space. So I have this pre-prepared code that I will be tuning right in this tutorial only, and we'll discuss along. So first, I have a couple of libraries like datasets, logistic regression, and random forest classifier, which I have imported from the subsequent libraries like linear model and ensemble. Datasets for using the inbuilt dataset iris, grid search CV for the model selection. Here, you can use the randomized search CV as well. There's one more library that we're using, which is called pipeline. So pipeline is basically very useful and comes in very handy from sklearn. So this functionality lets you run a sequence of sequence of functions, or you can say sequence of pre-processing steps, or be it anything. You can just run it in a sequence. You can just define it under the pipeline and they will be run sequentially one after the another. I'm just setting the seed random so that if you replicate it, you will get the same results. I'm loading the iris dataset. So all right, so iris is basically a flower dataset. Let me show you as well. We have the feature names like the length of the sepal, width, petal length, petal width. It's a very popular dataset and it has been used in many tutorials in the open source area. Now in the pipeline, right now I'm going to define only one algorithm, which is logistic regression, and I'm going to call it a classifier. So this just needs to be initialized because this cannot be empty. Another algorithm will go into the search space. So search space is nothing but the replica of the grid that we had prepared earlier. So along with the hyperparameters and their our user defined values, we have the name of the algorithm as well on which they apply. For example, for logistic regression, we have penalty and the strength of the regularization. Then we have this n estimators, number of trees, and the max depth in random forest classifier. So max depth is till how what extent you want to grow your tree. It has a default value as well. In case you want to check, you can check the documentation. Ideally, it is logged to the base 2 m cube, where m is the number of features. Now let's initialize our search space as well. All right, search space has been initialized. So it's basically a list of dictionaries, so just like this. Now let's initialize the grid. We have our estimator, which will be taken up from pipe and further on from the parameter grid, which is our search space. The cross validation is 5-fold cross validation. There is one more implementation of k-fold through from sklearn, which is k-fold actually, but we're not utilizing that separately because that divides the data into k-folds, and then we run our algorithm or maybe train our algorithm based those k-folds. So we are using the CV parameter, which does the same thing. There's one more very important parameter that we can use, which is njobs, which lets you utilize the maximum capacity of your machine. All right, so this might take some time. I'm just going to fit some values on the grid, and let's see. This is the njobs -1. I hope it doesn't take that much time. Yeah, it's training. Oh, okay. Let me stop it. Oh, it's done. I wanted to show you one more important parameter called verbose. So verbose displays the messages all along, so that okay, something is happening and you're not in the black box. All right, so yeah, it's it's printing some messages, and that it's doing certain tasks. It's throwing me a warning. Okay, increase the number of max iter. All right, we'll do that from the next time. Okay, now so we have got our best model. Now, this best model is actually out of grid search CV. So it just replicates what we have used here with along with the detailed expansion of all the hyperparameter values search space that we have created, or the grid we have created. Now for the best model, once it has been selected, we can check certain things. For example, best model dot uh, best estimator. Oh, I think I ran it again. Sorry. I need to. Sometimes I'm working on Jupyter, sometimes I'm working on Spider, so that's why it happens. Okay, so it says the best estimator for this model is logistic regression, which with the value of C as this. We can just say uh, get params. So we'll get the oh, oops, again shift enter. My bad. All right. So for this particular logistic regression, we have all the list of hyperparameters that are passed, like L1 ratio, maximum iterations, penalty. We were getting this increase the maximum number of iterations, tolerance. So we'll cover these hyperparameters in a detailed tutorial, but just for the sake of understanding, just see that you have got the best estimator out of these two, and our grid says that logistic regression is the would perform better on the given data set in the given set of hyperparameter scenario. We can also check it like this. We just see the score, that what kind of score are we getting. All right, so it gives around the 90 0.98. So this is basically kind of accuracy parameter, since we have classification and classification target variable, and sorry, categorical target variable, and it selects the accuracy by default. Or we can also use this dot best parameters. What are the best parameters? And it says, yeah, these three. So since we have defined only penalty and C, that's why we're getting the best params as penalty and C. But in get params parameter, we get all the hyperparameters that have been utilized in backend. So if you're thinking that we haven't used this in our while defining the grid, don't worry about it. Some of the values are set as default. For example, if I have to show you, I'll just get into the classes, class of logistic regression, and the code says the penalty, and for every penalty we have some default value everywhere. So for dual as well, we have default. For tolerance, we have default. It's 1 e minus 4 0.0004, which is like here. We have this value somewhere. Here. All right, so this is how it goes. Now, just like the last two recipes of model selection, we have again fit a model selection search, where we can select the best model, just like any other scikit-learn model. And yeah, that's more about it. Hey everyone, thank you for watching the video. I hope you liked it, you enjoyed it, and maybe I'm able to help you out with some quick implementations. If you really like the video, please do like and subscribe, and please do leave out your feedback in the comments. That would be really constructive, and I would really appreciate. If you have some pressing issue that you're unable to solve with respect to data science, machine learning, or AI, please do connect with me on my personal email, and I'll be happy to help you out. Thank you. Bye bye. Good day.